So this is our cyber magic grid. And the most important part about it is that we break down every product development process in 3 domains. Usually we start with a problem domain description. So in 1 sentence, what the system has to accomplish for the stakeholder. And for that, we will move through different pillars such as requirements, structure, behavior, parameters, but also early testing and governance that we will create throughout this problem domain description. And in this problem domain, we are looking at our product that needs to develop first in a black box perspective, meaning that we don't care about what is inside of the system, but only focus on the inputs and the outputs of the system. And after this is finished, we will look into the system once again in the white box perspective. So really thinking about what is inside of the system in order to make the outputs and the inputs flow to each other as specified before in the black box. And after the problem domain is described, we actually have a very good view about our product that we will need to accomplish for the stakeholders. And then we will jump into the solution domain, where we will think about how the system will work to fulfill these system specifications. So now we are jumping into direct solutions. The problem domain is solution independent, but the solution domain is dependent on individual, very specific solutions we use to actually satisfy the problem domain. And after these solutions are developed in the system architecture, last but not least, we have the implementation domain where we will include modeled hardware or actually also software code into the process. And I will just go through a very simple example of the EV car we have already talked about in the ModSim series to see how this actually looks like in the modeling tool. So starting with the problem domain, we start with the description. Starting with the requirements, we are specifying a system context. For example, for our car, we have the car, we have a driver, we have occupants or other vehicles in a smart city scenario that might be giving information to our electric vehicle in that sense. Then we can also say what our subsystems for this car looks like. So for example, we have an interior, we have a chassis, we have other system, we have an electric propulsion system that we will need to develop for that car. Then we will also need to specify how these systems are actually interacting with each other. So it's still based on the functional and the system architecture in that sense. After this problem domain has been defined, we go into the solution domain, where we specify the individual solutions. For example, in some sense of our ADAS system, we will need to create the solution for it. So example, this layout of the different cameras that are working together with our hardware controller that in the back end has some software code, or for example, in a heating and ventilation system, how these components are working with each other, and also for the propulsion system, which is also the main focus of this webinar series. So we are talking about specific solutions at that point already. And there also is the systems traceability, because in this process, we are also starting to create multiple artifacts, and we still want to know if we change the requirements, what other artifacts are influenced by the change of a requirement, so that I can see, for example, if I would change a high-level requirement, that some part of the electrical powertrain is directly influenced by that. So traceability is a very important aspect in that sense. And also, we are including early validation with simulation of the system level, for example, as it can be done in Daimler with the Modelica language in the background. So the system simulation aspect. And last but not least, how I mentioned it before, already the hardware and the software components are coming into the process in the implementation domain. So this is a very brief introduction of the cyber magic grid of Dassault. Then just a general overview for you who's trusting in our MBSE tools. So currently we are working together with multiple industries in the systems engineering, such as the healthcare industry, automotive industries, OEM, but also government companies, because they are using the enterprise modeling a lot. And we also have some customer references, for example, with Claas, ThyssenKrupp or Bosch in that context.